Hi everyone. In this session, we are going to discuss about the chapter Exponent and Powers. Based on this, we have 5 topics to cover in this chapter. They are base and exponent. Second one is exponential form. Third one is laws of exponents. Fourth one is numbers and expanded form. Fifth one is standard form. Now we will discuss about the topic base and exponent. For example, if we have 10 power 4, whereas this 10 is called as base, and the power and this power is called as exponent or power. This 10 is called the base and the power is called the exponent. And 10 power 4 is written as 10 power 4 equal to 10 into 10 into 10 into 10. It means 10, the base 10 is multiplied by 4 times. 4 times we are multiplying the base. Yes, so 10 power 4 is nothing but 10 into 10 into 10 into 10. And this is equal to, so how many zeros are here? 1, 2, 3, 4. So just write 1 and write the 4 zeros here. 3, 4. So this is the value of 10 power 4. Yes. And this 10 power 4, that is 10 power 4 is called as the exponential form. 10 power 4 is called as the exponential form. This 10 is called as the base and the power 4 is called as the exponent, and 10 power 4, the whole term, is called as the exponential form. For example, if we have 10 square, whereas again 10 is called the base and the 2, 10 is called the base and 2 is the power of 10, and this 10 square is written as 10 into 10, and this is equal to 1 into 1 is 1. We have 2 zeros. Just write 2 zeros. That's it. So 10 square is nothing but 10 into 10 because the power is 2. So we are multiplying the 10 into 2 times. The power, how many powers are here? 2. The power is 2. So we are multiplying the 10 by 2 times. So 10 into 10 is 100. And now 10 power 7 is nothing but 10 into how many times? It may be 7 times because the power is 7. So we are multiplying the 10 into 7 times. 1, 2, 3, 4, 5, 6, 7. So we are multiplying the 10 into 7 times. And this value is equal to, just write 1, and how many zeros are here? 1, 2, 3, 4, 5, 6, 7. 7 zeros are here. So just write 1, 2, 3, 4, 5, 6, 7. Just write 7 0. In this case, we have the power of the exponential form is positive. Suppose if the power of the exponential form is negative. For example, if we have 10 square, this is equal to 10 into 10 and this value is equal to 100. Suppose if we have 10 power 1. 10 power 1 is nothing but you are multiplying the 10 by only 1 time. 10 power 0. 10 power 0, that is anything power 0 is nothing but 1. 10 square is equal to 10 into 10. This is equal to 100 because we we are multiplying the base 10 into 2 times. So 10 into 10 is 100. Next 10 power 1. So we have the power as 1. So we are multiplying the 10 by 1 time. Next we have 10 power 0. Anything power 0 is 1. Not only the 10, any number raised to the power 0 is 1. What happens if we have a negative power? For example, if we have 10 to the power minus 2. 10 to the power minus 2. If the power is negative, just reciprocal the base. For example, if we have 10 to the power minus 2, this is equal to just reciprocal the base. Here we have base is 10 and its reciprocal is 1 by 10. And automatically this power turns, that is the negative power, turns to positive. Yes, we can write the negative powers of the base in 2 ways. For example, if 10 to the power minus 2, we can write it as, we have the power is negative, so just bring the power to be positive by shifting the base to the denominator. If we have the power is negative, just bring the base to the denominator and write the power 2. Or you just reciprocal the base and write the power to be positive. Yes, if it is 10 to the power minus 7, then you can write the 10 to be 10 to the power plus 7. I just bring the 10 to the denominator and wrote the power to be positive. Or I can write the base 10 to the power minus 7. This is equal to, I can write the base 10 as 1 by 10 because I am reciprocaling the base 10 as 1 by 10 and write the power to be positive. This minus 7 turns to the positive 7. Next we move on to the topic exponential form or exponential notation. For example, if they given 1000, the number 1000. So the given number should be factorized first. So 1000 is factorized and we will have this is the final answer. So the factors are 10 into 10 into 10. So 1000 can be written as 10 into 10 into 10. So how many tens are here? We have 3 tens. These are the factors. So we are writing the 1000 as 10 into 10 into 10 and this can be written as 10 to the power 3. Because as I said before, here we have multiplying 10 by 3 times. Here we are multiplying the 10 by 3 times. So the power should be 3. Yes, so this is in the form called as anything power. Anything power is called as the exponential form or exponential notation. One more example, if you have 625, then you can factorize this 625 and the factors of 625 is 5 ones are 5, 5 twos are 10, 5 fives are 25. Again 5 twos are 10, 5 fives are 25 and this is divided by 5. Again 5 ones are. So 625 is written as 5 into 5 into 5 into 5 because the factors of 625 is 5 into 5 into 5 into 5 into 5 into 5. So 4 5s are here. So here we are multiplying the 5 by 4 times. So we can write the base as 5 and the power is 4, because we are multiplying the base 5 by 4 times. So 5 to the power 4, and this is in the form of exponential. So this can be said as exponential form or exponential notation. Next we move on to the laws of exponent. So we may have 7 laws of exponents. They are listed here. The first law is a power m into a power n is equal to a power m plus n. That is, if the base is same, if we have the base is same and the power is different, and the important thing is in between that, if we have a multiplication, then write the same base as it is and add the power. Yes, if the base is same, just write the base and add the power only if they given the multiplication sign. For example, if we have 2 power 3 into 2 power 2. This is equal to, the base is same. So just write the base. Only if the base is same, just write the base. And add the power. Because of they given the multiplication sign, so we have to add the power. And this is equal to 2 to the power 5. And this value is equal to 2 into 2 into 2 into 2 into 2. 5 times 1, 2, 3, 4, 5. 5 times. So this is equal to 32. So first law we verify. A power m into a power n is equal to a power m plus n. That is, if the base is same and if you have the multiplication sign in between that, then write the same base as it is and add the power. Next law, a power m divided by a power n is equal to a power m minus n. Yes, so here, as I said before, the base is same. In the numerator and denominator, we have the same base and the power is different. And important thing is, here we have division. For division, you have to write the negative sign in between. That is, if a power m divided by a power n, that is, we have the same base here, just write the base, and in between the term we have divided sign, so we have to write the power as m minus n. That is, if we have that division sign is turned to minus. If the term is divided, then the power should be subtracted. If the term is multiplied, then the power is added. For example, 2 power 4 is divided by 2 power 3. Here we have the base as 2. The base is 2, so write the base. And the power is 4, 3. 4, 3. So here in between that we have to plus or minuses. Here we have the division, so we have to write the minus sign. If it is multiplication, then you have to write plus. If it is division, you have to write the minus sign. So this is equal to 2 power 4 minus 3 is 1. So 2 power 1 is nothing but 2. Third law is a power m to the power n is equal to a power m n. So for example, if we have 3 power 2 to the power 4. This is equal to 3 to the power 2 into 4. And this is equal to 3 power 8. One more example is, if you have 10 to the power 2 to the power 3 to the power 5, then just write the base and multiply the powers. That is 2 into 3 into 5. And this is equal to 10 to the power 2 3s are 6, 6 5s are 13. So 10 to the power 13. So wherever, if it is 4 number or 5 number or 7 number, whatever the powers they are given, just write only the base and multiply all the powers. So this is the third law. Fourth law is a power m into b power m. So this is equal to a into b to the power m. That is ab to the power m. Yes, for example, if you have 3 to the power 5 into 2 to the power 5. Here we have a different base. Base as 3 and 2, and we are multiplying 3 power 5 into 2 power 5. This is equal to, just write the base within the bracket and write the same power outside. And this is equal to 2 3s are 6 to the power 5. So the fourth law is a power m into b power m equal to a into b to the power m. And the fifth law is a power m divided by b power m. This is equal to a by b to the power m. For example, if we have 3 power 2 divided by 4 power 2, this is equal to 3 by 4 to the power 2. And the sixth law is a power 0 equal to 1 and a power 1 equal to a. For example, if we have, already I said, anything power 0 is 1. For example, 2 power 0, this is equal to 1. 3 power 0 is equal to 1, because anything power 0 is equal to 1. Either it may be 1,000 or lakhs. Whatever the number to the power 0 is 1. Yes? If we have a power 1, that is 5 power 1. 5 power 1 is, we are multiplying the base by 1 time. That is only 1 time. And 3 power 1 is nothing but 3. And 1000 power 1 is nothing but 1000. Next, we will look at the seventh law. Seventh law is 1 power a equal to, the value is 1. 1 power a is equal to 1 only if a is an integer. A is an integer. Minus 1 to the power a is equal to plus 1. Minus 1 to the power a is plus 1 only if the power a, is even. If the power is even, then minus 1 to the power is equal to positive 1. If the minus 1 to the power a is equal to minus 1, only if a is odd. Only if a is odd, that is the power is odd. So we will verify this law by examples. Minus 1 to the power 3. This is equal to, what is the value of minus 1 to the power 3 is, we are multiplying the minus 1 into 3 times. That is, the power is 3. So we are multiplying the base is minus 1. So we are multiplying the minus 1 by 3 times. And this is equal to minus 1 into minus 1 plus 1. Plus 1 into minus 1 is minus 1. And we have this 3 is a odd number. So if the power is odd, we have a minus 1 to the power is minus 1. If we have the minus 1 to the power 4, whereas 4 is an even number. So for example, if you have minus 1 to the power 4 is, we are multiplying the base to the power 4 is minus 1 into minus 1 into minus 1 into minus 1. That is, we are multiplying the minus 1 by 4 times, and this is equal to minus 1 into minus 1 is plus 1. Again, minus 1 into minus 1 is plus. So plus 1 into plus 1 is plus 1. So we prove the condition, if the power is even, we have a positive 1. The power is even, right? So we have a even power, so the value is plus 1. If the power is even, we have plus 1. If the power is odd, we have a minus 1. So we have verified the 7 laws by some examples. Next, we will discuss about the topic numbers and expanded form. For example, if we have 8, 1, 2, 6, 7. This is a given number and you have to expand this number as 7 is in the ones place, 6 in the tens place, 100, 1000, 10,000. Yes? So 7 is in the ones place, 6 in tens place, 2 in 100 place, 1 in 1000 place, 8 in 10,000 place. So you have to expand this given number in an expanded form. That is 8 in the position of 10,000. So you have to write 8 into 10,000 plus 1 is in the position of 1000. So 1 into 1000 plus 2 in the place of 100. So we have to write 2 into 100 plus 6 is in the place of tens place. So 6 into 10 plus 7 is in the place of ones place. So 7 into 1. So this is the way you have to expand the given number. So this is an integer. So you are expanding the integer number in this way. Now let's see how do we expand the given decimal number. So here we expanded the given integer. So next example we are going to see is, if the decimal number is given, we are going to write it in a expanded form for the decimal number. For example, if we have 7, 3, 4, 8.59. So this is an integer and this is an decimal number. Yes. So we are going to write this number in an expanded form. So first we have to expand the number before the decimal point. So this is in ones place, tens, 100, 1000. Okay. So 7 is in the thousands place. So 7 into 1000. Next 3 is in the hundreds place plus 3 into 100 plus 4 is in the tens place, 4 into 10 plus 8 is in the ones place, 8 into 1 plus, now look at the digit comes after the decimal point. Here 5. 5 is the number digit comes after the decimal point and the position of the 5 is 1/10. TENTHS, tens place. So 5 into 1/10 place plus 9 is in the position of 1/100th place. 9 into 1/100, HUNDREDTHS, 100th place. So this is the way you have to expand the given decimal number, and this is equal to 7 into 1000. So 7 into 10 to the power 1, 2, 3. 3 zeros are here, so power 3 plus 3 into 1, 2. 2 zeros are here, so 10 to the power 2 plus 4 into 10 to the power 1 plus 8 plus 5 into 10 to the power 1. So 1 by 10 to the power 1. 1 by 10 to the power 1 can be written as 10 to the power minus 1, because here we have the base as in a reciprocal form, so we bring it to the numerator and the power becomes the negative. Positive power becomes negative. If 10 to the power 1, if 10 power 1 goes to numerator, then this is equal to 10 to the power minus 1. Suppose if we have 1 by 10 square, then this is also equal to 10 to the power, it goes to the numerator, then we have 10 to the power minus 2. Yes, so we have 8 into 1 is 8 plus 5 into 10 to the power 1 is 5 into 10 to the power minus 1. Here we have power 1 plus 9 into 1 by 100 is nothing but 1 by 100 is equal to 1 by 10 square, and this is equal to 10 to the power minus 2. So 9 into 10 to the power minus 2. So this is the way you have to expand if the decimal number is given. Finally, we comes to the last topic as standard form. How to write the given decimal number in a standard form. If the given number is in the standard form, then it should have 4 points. That is, first one is one natural number should be there, followed by the decimal point. After the decimal point, few numbers will be there, and then exponent number will be there. For example, if they given as 9.3721 into 10 to the power 5. This is the number, it is in the form of standard form, because for the number to be in standard form, if they have the 4 condition, first one is the decimal point should be strictly after the one number, that is the decimal point should be after one natural number. After the decimal point, there may be any number, but before the decimal point, there should be strictly only one number. And then we have a exponent form of number here. Okay, so 4 condition is natural number should be there, only one natural number should be there, followed by a decimal point. After that we have any number of numbers, and then we have a exponent form of number. So all the collection or combination of these conditions make to be a standard form. For example, if we have the number as 34.682, this decimal number is in the standard form? No, because before the decimal point we have 2 numbers, but for the number should be a standard form, we should have only one number before the decimal point, but here we have 2 numbers, so we have to convert this number into standard form, so that we have to rewrite the term number as 3 point, because only one number after the decimal point, 3.46882. Write the remaining all the numbers. And how many numbers we are? We are shifting the decimal point to one number. That is, we are shifting the decimal point to one number. That number is 4. So we have to write 10 to the power 1. If it is, if the next example is 723.698. If it is like this, then we have to write this number into standard form as 7 point. Write 7 point and then write all the remaining number as 23698 into 10 to the power. We are shifting this decimal point before the two numbers. So we have to write 10 to the power 2. Suppose 86946.5.32. If it is like this, decimal point is like this, then we have to write 686946532. Just write all the number and then shift the decimal point just after the one natural number. 8.6946532. So how many numbers we are shifting the decimal point to? The number is 1, 2, 3, 4, 5. So you have to write into 10 to the power 5. So this is in the form of all this and all is in the form of standard form. Next, we are going to convert the given standard form of number into usual form. Now, we are going to convert the standard form of number into usual form. For example, 4.76 into 10 to the power 5. This is in the form of standard form because we have one number. After the one number is, we have decimal point and we have some number, and then we have the exponent form. This is a standard form of number. Now we are going to convert this standard form into usual form of number. How we have to write it is, first take this number 4.76. This can be written as 476 divided by how many numbers are there? Two numbers. After the two numbers we have decimal point, so we need to put 2 zeros. So if we divide 476 by 100, we will get this number. So how many numbers are there from right to left? The decimal point is there, then write the number of zeros there. And this is equal to, this number is equal to 476 divided by 100. 10 to the power 5 is 10 into, so 10 to the power 5 is nothing but 10 into 10 into 10 into 10 into 10. So 5 tens are here. So 1, 2, 3, 4, 5. 5 zeros we need to put. 2, 3, 4, 5. So 10 to the power 5 can be written as 1, 2, 3, 4, 5. Yes. So just divide the two zeros as it is. So 476 into 1, 2, 3, 1000. So 476,000. This is the answer. In another way, we can write it as, using the laws of exponent, we can write this as 4.76 into 10 to the power 5. This is equal to 476 by 100, no? So we have to write 10 to power 2. This is equal to 10 to the power 5. And this is equal to 476 into 10 to the power a power m divided by a power n is a power m minus n. So 10 to the power 5 minus 2 is, so we have to write this as 476 into 10 to the power 3. 5 minus 2 is 3. So 10 to the power 3, this is equal to 476 into 1000. Again this is equal to 476,000. Now you may have a clear idea about base and exponent, laws of exponent, exponential form, numbers and expanded form, and standard form. So if you like this video, please like, share and subscribe our channel. Please keep on support our channel. Thank you.